Series circuits practice 2. Number 1, sketch a series circuit with a 30 ohm resistor, 150 ohm resistor, and a 100 volt battery. Include an ammeter that is going to read the current through the whole circuit, and a voltmeter that will read the voltage drop across the 50 ohm resistor. All right, so first of all, they tell you that this is a series, they tell us that this is a series circuit. That's important. For our circuit, we are going to start out with a battery. Okay. This battery, we are going to connect a 30 ohm and a 50 ohm resistor. So the first thing that we have here, we want to include an ammeter that reads the current through the whole circuit. This is a series circuit. We know current is the same everywhere, so we can put this ammeter wherever we want. So I'm going to start out with my resistor here. You definitely are not graded on how beautiful your picture looks as long as your diagram is correct. Okay. I have another resistor right over here. And I'm going to add my ammeter so that it's on the same path as my battery, and it looks like this. I'm going to label this resistor 30 ohms. I'm going to label this resistor 50 ohms. And because I want a voltmeter to read my 50 ohm resistor, I'm going to place my voltmeter right over here so that it is only connected to my 50 ohm resistor. The battery, they tell us, is 100 volts, and that's what our circuit should look like. So for letter A, calculate the equivalent resistance. My formula for a series circuit, Req, is equal to R1 plus R2 because I have two resistors here. I have 30 ohms plus 50 ohms to give us a total equivalent resistance of 80 ohms for our circuit. For letter B, determine the current flowing through the circuit, the overall circuit. Well, if I'm looking for my overall circuit, then that means I'm looking for my total current. Totals must go with totals. So if I know that my total voltage is 100 volts, I'm looking for my total current, and that has to be associated with my total resistance of 80 ohms, which means that my total current has to be 1.25 amperes. Calculate the voltage drop across the 50 ohm resistor. If we're looking for voltage, we are going to use V equals IR. We are looking for voltage, 1.25 amperes multiplied by my 50 ohm resistor. The voltage across my resistor should be 62.5 volts. For letter D, compare the current that passed through the 30 ohm resistor to that of the 50 ohm resistor. This is a series circuit. And in a series circuit, current is constant always. That's what a series circuit, that is one of your series circuit rules. So current is constant in a series circuit. So your current, no matter where you are, should be 1.25 amperes. For letter E, calculate the voltage drop across your 30 ohm resistor. We want to know, well, first, what is your voltage for the 30 ohm resistor? So we can solve for that using V equals IR. 30 ohm resistor, we know that we have 1.25 amperes multiplied by 30 ohms. The voltage across this resistor is 37.5 volts. So the next question should be, well, how does 37.5 volts relate to the 62.5 volts that we already solved for? Obviously, 37 is less than 62, which means that your 30 ohm resistor has less voltage than the 50 ohm resistor in the circuit. For the next page, we're given a circuit, a series circuit that has lots of resistors. So they give us 6 resistors, which means that we need to make sure that we account for all of these when we draw our VIR chart. So for number 1, we want to create our chart such that we have V, I, R, and P all going across the top. We want to make sure that we're including our 6 resistors as well as a row for our totals. So we have R1, R2, R3, R4, R5, R6, and REQ. Yes, it's a big chart, but big deal. You're able to do this. You know the math. So you just have to make sure you're organized. And this is why we use a chart, because we need to make sure we're organized. All right. So we're going to create our chart here. We're going to go through, we're going to do the math and make sure we're all on the same page. So the first thing that we can do, we can go through and we can label our resistors. That's what we definitely should do first. So R1, they tell us, is 2 ohms. That's a given. R2 is 4 ohms. R3 is 7 ohms. R4 is 10 ohms. R5 is 9 ohms. And R6 is 5 ohms. Okay. They also tell us here that I have an ammeter. This right here is my ammeter. And there are 2.5 amperes flowing in my circuit. Well, this is a series circuit, which means that 2.5 amperes is constant everywhere. So I can go ahead and add this into my chart here as well. Don't be intimidated by how many rows you have. It's just a little bit of extra work, a little bit of extra math. All right, so then, what I want to do next, I'm going to solve for REQ first. So let's separate this here. So if I solve for REQ, I have my formula. And again, all you're doing is including as many variables as is given to you. So we have 6 resistors. That's 2. So we have 2 plus 4 plus 7 plus 10 plus 9 plus 5. Okay, let's do the math here. 2 plus 4 plus 7 plus 10 plus 9 plus 5 should give us a total of 37 ohms for our resistance. Okay, solving for V, I'm going to do the work right in here. We end up using V equals IR for this entire column, right? So I'm just going to write it once so that we could just go through and do the math. But V equals IR is what we're using for the whole row, the whole column. So we have 2.5 multiplied by 2, which is going to give us 2.5 times 2, obviously going to give us 5. Definitely did not need a calculator for that. 2.5 multiplied by 4. 2.5 times 4 is going to give us 10. So this is 10 volts. 2.5 multiplied by 7 for the next one should give us 17.5 volts. 2.5 multiplied by 10, again, I definitely did not need the calculator for that. That should give us 25 volts. 2.5 multiplied by 9 for our 5 should give us 22.5 volts. 2.5 multiplied by 5 should give us 12.5 volts. Multiplied by 5 gives us 12.5 volts. So now we get to our total voltage all the way here on the bottom. If we are using our formula, V equals V1, and this is be our total, V1 plus V2 plus V3 plus V4 plus V5 plus V6. We can go ahead and plug in all of our information. 5 plus 10 plus 17.5. I'm literally just getting the numbers right from my chart. 25 plus 22.5 plus 12.5. Our total voltage, 5 plus 10 plus 17.5. It's 25 plus 22.5 plus 12.5 should be 93.5 volts. Now, if we want to check ourselves, just to make sure, I can go ahead to check. I can go ahead and I can say V equals IR, my total voltage of 93.5. I'm going to go ahead and make sure my current is correct here, and my total resistance of 37 ohms. 93.5 divided by 37 gives us 2.53, which does round to about, we'll use this little congruent sign here, about 2.5 amperes. So we know that we did all of our math correctly. So now the rest of this question, number 2, how must ammeters be placed in a circuit? Well, ammeters must be placed inside of your circuit or in series with your circuit. They have to be placed on the same line as your battery is. How must voltmeters be placed in a circuit? Voltmeters must be placed on the outside of your circuit, which is why we go ahead and we add them to your circuit like this. For number 4, describe the relationship between current and resistance in a circuit. Well, according to Ohm's law, current and resistance are right next to each other. So mathematically, we know they have an indirect relationship. So as one gets bigger, the other one should get smaller. For the last page of your homework here, what is the voltage reading in voltmeter V for this number 1? Okay, well, we're looking here and we want to know what is the voltage going through the 20 ohm resistor. It's good if we make a chart for this because if not, it may be difficult for you to see what's happening here. So we have 2 resistors, so we have R1 and we have R2. We also need REQ for our total. Making a chart should take us very little time. We have V, we have I, we have R. Why do we have to solve for power if we don't need to? So we don't put it. We know that we have a total of 60 volts. Our battery is 60. We also know that we have 2 resistors. One is 20 ohms. The other is 10 ohms. And they want to know what is the voltage reading through voltmeter V, which means that they want to know what is the voltage through 20 ohms. So they're looking for this piece right here. Okay, so what we first need to do is we need to fill in what we don't know, something that's going to be able to help us solve this problem. And that is going to be our total resistance, our REQ, right over here. So if we solve for REQ using our formula, we end up with 30 ohms for our REQ. Once we know that, we can then go ahead and we can solve using V equals IR for our current. So 60 volts equals I multiplied by 30 ohms. Our current is going to be 2 amperes. And because this is a series circuit, we know that current is the same everywhere. So our last step to solve for this missing V right over here, we can go ahead and we can use V equals IR to solve for that. We end up with 2 multiplied by 20, and we end up with our answer of 40 volts. For the second picture here, what is the current through the 5 ohm resistor? Well, we know current is constant, so again, we can make a table. We have R1, we have R2, we have REQ. Again, making a table takes no time at all to do. I made an extra line here. It takes no time. Quickly jot it down so that you can organize your information. So we have our total of 9 volts. We have one resistor of 4 ohms. We have another resistor of 5 ohms. That looks like an S, but it is a 5. And we want to know what is the total current, or what is the current for that matter. So we're looking for this column. Well, what I can first solve for is my total resistance. And I know in my series circuit, I add all of my resistors together. So my total resistance is 9 ohms. If I go ahead and I use the formula V equals IR, I could get 9 volts equals I multiplied by 9 ohms to give us a current of 1. Lastly, number 3, a set of resistors is connected in series. Adding resistors to this circuit in series with the others will, well, if I want to know what happens to my resistance, again, as I keep adding my resistance to my circuit, I don't want V, I want R, I want to know what happens to my equivalent resistance, what happens to REQ. And according to my formula, the more resistors I add, the greater my REQ gets. I just keep adding them together. So what's going to happen? I'm going to increase my equivalent resistance.